The idea of perimeter defense is as old as the history of warfare. Ancient cities had fortress walls, as did castles and great empires like Rome and China. Army field manuals the world over talk about establishing a perimeter. So when it comes to network security, the idea of setting up a secure perimeter is only natural. Many types of network devices can contribute to that boundary that demarcates a local network. But one device above all, known by its colorful name, best represents the spirit of network perimeter defense. That device is the firewall. Before we look into the technical dimensions of firewalls, we should first consider the type of security strategy that benefits the most from the presence of firewalls. That strategy is called defense in depth. The idea behind defense in depth is that many layers of technical, physical, and administrative controls should stand between your assets and any external threat. In a defense in depth system, a firewall may have symbolic meaning as the essential element on the local network's edge, but the firewall will not be acting alone by any means in the prevention and interception of possible attacks. Good network design can aid the firewall in its defensive mission, as can good network management, PC desktop policies and maintenance, user education, and a clear and enforceable acceptable use policy.
One of the things that I get asked pretty frequently are what are some technologies that are preventative or detective for cyber attack and doing the work necessary to prevent them. The standard simple things are typically the things people overlook the most. So we'll talk about process and methodology in the business. We'll talk about the people and their acumen, and then we'll talk about technology like firewalls and IDS, IPS, and antivirus, and more complex things now as the next-gen firewalls come to bear, as well as malware detection and analysis products. And when we start to add those pieces together, we include packet analysis, and we include other things like flow analysis. That's the data collection piece for visibility. Then we get into analytics and how we make that data useful for everyday cyber warriors.
Sometimes managers are tempted to view the firewall as a kind of one-shot silver bullet style security solution. There is an irreverent name for that sort of network design. It's called a lollipop. Hard shell on the outside, soft and chewy in the center. By contrast, a network designed for defense in depth is more like an onion. Multiple layers of protection and reasons for an intruder to shed tears at any given layer. There is no point in considering the role of the firewall in a lollipop network design. It's not the right tool for the job because the job is a bad idea in the first place. Instead, we will be considering firewalls from a defense in depth perspective, like what security functions are best performed at the firewall and what functions make sense at other network locations. To understand how firewalls work, it's first important to understand how networks work. This is not the place for a thorough introduction to the theory and practice of networking, but a few key ideas are worth mentioning. First of all, network communication is divided into logical layers. The most widely mentioned networking model is the Open System Interconnection, or OSI, 7-layer model of networking. In the 7-layer model, each network layer has one or more particular jobs to do within the total system of network communication. The first layer is fairly easy to understand. It's the physical layer. This physical layer just transmits physical signals such as electric, photonic, or radio to the other end of a link. The only interesting question about a firewall at the physical layer is it properly plugged in? This question is not trivial, but it's also pretty easy to answer. So let's turn our attention to the other network layers. The second layer in the OSI model is called the data link. The data link layer needs to frame messages for transmission over the air or over the wire. Data link technologies address their message frames with addresses that have purely local significance. By comparison to the physical world, a link level address might be compared to something like the White House or the West Gate. If you are already close, the address might mean something, but a Layer 2 address is of no use for guiding traffic on the global internet. Because network firewalls typically operate at the demarcation point between local and global networks, They do not usually have much to do with data link layer security. The network device called a switch can provide extra layer 2 security behind the firewall. Thus, hardening switches behind the firewall is a good defense in depth concept. Firewalls come into their own as we climb the network stack to layer 3, the network layer. The network layer is the province of Global Internet Protocol, or IP, addressing. IP addresses on a layer 3 packet tell network devices where in the world a packet is coming from and where in the world a packet is going. That's where firewalls now have a job to do. Is a particular attack known to come from a specific foreign country? Then the firewall can block all those IP source addresses. Is a particular source IP address known to be trusted? Then the firewall can let those messages pass right through. The firewall basically acts like a postal inspector, deciding which messages to deliver and which to toss in the trash. Layer 4, the transport layer, is where traditional firewalls probably work the hardest. The transport layer is where application payloads are groomed and segmented for network transmission. Think of the transport layer as a combination gift wrapping service and parcel post delivery courier. Application data is what you want to send. The transport layer puts shipping labels on this data, indicating special handling and describing to the receiving side what type of application traffic is in each packet. The transport layer does this work with a special address called the port number. Every application gets its own port number. Some applications use multiple port numbers. So by inspecting the port number, the receiving side should be able to tell which application will be using the incoming data. Network layers 5 through 7 have to do with the applications themselves. We will not go into the details about these layers. Just remember that application payloads are on top of the network stack. So the way data networks function is to start with an application payload, then wrap this data with a layer 4 header. That in turn is wrapped in layer 3 and layer 2 headers. The resulting frame, a payload with at least 3 different headers, is then turned into signals and sent out over layer 1. Firewalls typically inspect layers 3 and 4 in the middle of these network frames. They leave layers 1 and 2 processing to the local switches, and they do not, in general, peer into the application itself. This packet filtering pattern for layers 3 and 4 inspection only were most typical of firewalls in the 1990s. However, over time this pattern has become less and less useful. The reasons for this have to do with the success of the World Wide Web. Once upon a time, every application ran on its own distinctive port number, and network administrators had a huge amount of leverage regarding which applications could go in and out over the network. However, users and developers got tired of waiting for administrators to open ports, so they came up with the idea of tunneling everything over port 80, the World Wide Web. In today's environment, a large proportion of application traffic, email, database, file transfer, social media, video streaming, and many more rides over Web port 80, or its secure cousin, port 443. No network administrator who wants to keep a job would ever consider blocking users off from port 80. So port 80 is like a door propped open all the time. Every kind of network traffic, good, bad, and ugly, goes right through port 80 if a packet filtering firewall is the only line of defense. For this reason, using a packet filter on the network's edge as the sole line of defense is the flimsiest of lollipop designs. More recent firewalls recognize the port 80 problem and address it through what is called deep packet inspection. Deep packet inspection means examining the application payload and looking for malware signatures within that payload. The great majority of current network attacks involve finding flaws in web-based applications. So web application firewalls have been developed to perform deep packet inspection and to identify web application attacks on the way in. At the web application level, firewall functionality shades into related areas such as spam filtering, antivirus, application proxy servers, or network load balancing. Some devices combine firewalls with many other features to create all-in-one security appliances. Likewise, firewall functionality can be added to other devices like routers, servers, and desktops, so packet filtering can occur in front of or behind the classic firewall at the network edge. Given the size and complexity of the modern data center networks, it would be unusual to see a standalone device called a firewall through which everything has to pass. But packet filtering and deep packet inspection are bound to be deployed in such data centers, possibly in the form of virtual firewalls embedded in other network elements. If we compare perimeter defense to a medieval castle town with its walls and moats and pots of boiling oil, Port 80 is essentially a drawbridge that is left open all the time so everyone can go in and out of the main gate. Both legitimate and illegitimate business travel is going to pass through that portal. More critically, just as cities long ago learned to function without castle walls, modern data networks are learning to function without a network perimeter. The portal to current cities is not the drawbridge, it's the airport. And the portal to current data applications is not the local firewall, it's the cloud. How can data be kept secure when it leaves the local network perimeter and travels to data centers in the cloud? We'll explore this question in our next lesson on cloud security.